So yeah, I have the privilege of being the second to last to present. This is actually the first time I've ever spoken at one of these conferences. So my third year at at GDevCon N.A, and I'm grateful and honored. So today I'm going to talk about user interface abstraction. I had to put fun in it because, you know, it sounds like it's a really dry topic. But so who am I? I have been drawing pictures that make computers, robots, and blinking lights do things for quite a while now. I've been moving squares and lines in LabVIEW almost every day for over 21 years, which is kind of hard for me to believe. I'm a dual architect, so I am a certified LabVIEW architect and more recently a certified test stand architect. And I've been writing test stand code, for better or for worse, almost every day for almost 10 years. I actually like LabVIEW quite a bit better, but I'm good at test stand, so I do that. I also have another credential, which is the best of them all. I'm a proud member of the Society of Instructors Who Can't Be Trusted to Access Course Material Anymore.
That's not okay. Let me know if I can help.
I can parallel park a fire engine. You might wonder what this picture is about. Before I switched to engineering, I was actually pursuing a degree in performance for horn, and that is a very much younger me during a recording session with a wind ensemble. Throughout engineering school, I was the only non-music major in almost all the ensembles, which was kind of fun. It was a nice outlet. I listened to people who convinced me that I would never make it. I should have listened to my music professors. But then everything that followed wouldn't have happened, and I wouldn't be here. So I'm grateful regardless. When I graduated with a computer science and engineering degree, I worried that I might not be cut out for engineering. School did not come easy for me. And my advice to, if you're watching this later on or you're a young engineer, you can absolutely do this. Have confidence. Right out of school, I'm grateful to a well-known alliance partner that hired me and gave me a chance. The owner told me years ago, because I thanked him several times, he said, stop thanking him for hiring me. You know who you are, and yes, I'm still grateful. So after coding in C++, assembly, Java, that was sort of the point where I was like, I don't know if I'm going to like this. LabVIEW just clicked. And of course, this is kind of cheesy dad joke. A light went on in my visually wired brain, so I had to put the light there for the execution highlighting. And then an entire career followed, so here I am. So I work, a few disclaimers here. I work for a business unit of a huge corporation, and you probably know what that is. It has a logo that looks remarkably like the Golden Gate Bridge. I am here representing myself. I didn't really ask for permission from my employer. This presentation is not necessarily endorsed by my employer. My words and views are my own. And there are also others in this room that use the techniques I'm about to talk about, and they may do it better than me. And so if you, at any point during this presentation, there's something that you can correct me on, or there's a better way to do it, I'm very interested. Yeah, this is a silly thing that the authenticity is somewhat in doubt. Apparently there's a train station in London where someone posted this sign as a joke as the level 5 goose warning. It seemed apt for a boring disclaimer. So, about this presentation, it's not, I don't want this to be an intimidating academic discussion of solid principles as they relate to user interfaces, the Gang of Four design patterns, which I made a silly graphic for, which apply to all facets and minutiae of life, as you well know. Deterministic finite state autonoma, Chomsky's syntactic structures, or the social peculiarities of Eudiptula minor penguins. All these things are very important in context, though. But this is supposed to be accessible for everybody. It's not a terribly advanced presentation, but hopefully you can all find some practical use for at least some of this knowledge. Yeah, so. What is UI abstraction? Ideally, it's being able to make your application agnostic of the user interface. So you could have an application, and without much effort, you could change user interfaces, and you could rearrange them, or depending on how they're used, present them in a different way to different users. Some goals should be, a UI should be extensible without modifying the underlying code and class. You should be able to substitute one UI for another without modifying the underlying code. The UI should only present, I mean, you don't have to follow this, but ideally your UI should only present the controls and the indicators that a given user or context needs. So I think early on in my career, like one of the things that I called, when I saw a user interface where someone tried to pack every single controller indicator onto one screen, to me it looked like, I would imagine like the space shuttle with like the entire ceiling that's covered with controls and switches, which are necessary if you're flying a space shuttle. But to me, I was like, I don't want to design a user interface like that. So why would you use this? And speaking of things aeronautical, the best thing I could think of was a glass cockpit. So depending on the aircraft that you're flying, and I'll admit I know nothing about avionics, you might want to present different customers with different UI preferences. So you might have the same device that's doing the same thing in a different aircraft, but you want to present it differently. You have multiple screens. Maybe there's one device that's presenting several user interfaces, and you might want to configure them differently. You have 3 similarly manufactured products with different physical components, and I've actually done this in a prior job. Or you're being a lazy engineer. You're tired of writing new UI handling code for every new application. All right, so really basic stuff here, and I'll try to go quickly through this. So LabVIEW user interfaces throughout the ages. So this is like the spaceship Earth ride at Epcot. This is sort of like the woolly mammoth stage. So what we all first learned about in LabVIEW, the absolute fastest way to update an indicator is, of course, the terminal on the block diagram. And data flow is good. This has some disadvantages. You can't write to an indicator directly from a sub-VI or another VI without some queues, notifiers, or whatever it may be. So that introduces some overhead automatically. You've got to explicitly wire to each indicator terminal because we're still in data flow land, and I already touched a little bit on the developer overhead. So let's break data flow. It's high time. So the way that I understand data flow is you have to follow one wire to exactly where it needs to go, and the data does not. I'm not explaining this well. Well, here's what it's not. You can convey data without a directly wired connection. So local variables let us do that, for instance. It sets us free to make some more complex architectures, and race conditions are now a thing. So talking about local variables, only slightly slower than writing to an indicator terminal. Of course, they break data flow, which has advantages and disadvantages. Multiple parts of the code can write to an indicator at the same time. And it has basically the same disadvantages as writing directly to a terminal. And no, I'm not going to talk about LabVIEW global variables, why they're an odious abomination, and their heretical uses in test stand, because test stand's a very strange animal. All right, so now we're elite. We have property nodes, explicit ones. So now we have the ability in sub-VIs or other VIs entirely to write to an indicator. We could deeply nest modules that can directly access code, controls and indicators, and it sets us free to begin abstracting the UI. Disadvantages are you can, of course, make awful spaghetti. It runs in the UI thread. It's slower than a sedated sloth because of that, because it's in the UI thread. And your LabVIEW UI will probably suck. Not necessarily. This is the way that I used to abstract out user interfaces. So I don't know if anybody here has benchmarked it, but I made a benchmark, and I can show it if you'd like. But so a terminal update, so I have 1 million indicator updates and how many seconds it took. So the terminal update is, of course, the gold standard, and then I measured how much longer it takes for each of these methods to work. So local variable is pretty much on par, maybe a little bit slower. Value properties are, in this case, 500 times slower. So if you're using value properties, try to avoid it because they're really, really slow. And it depends on several factors. If you have a few of them, then it ends up being much longer, it takes much longer than a terminal update. And even if done neatly, things get out of hand quickly. And then you get into the worst case scenario, and the credit goes to TST. I'm not sure if that person, I don't know who they are in real life, but I solicited on the forums. I'm like, show me some really bad examples of control references. And there's a comment in here. It says, this whole honking section just sets up arrays of references. Oh, I should probably, yeah. This whole honking section sets up arrays of references so I can deal with them more modularly as I configure the controls. Okay. And that VI is about this long. So I was like, wow. On the forums, I was like, this is a great example. Thank you so much. Obviously, it's the worst case scenario, and most of us aren't going to write something like that. But then you feed the LabVIEW trolls that are like, why I hate LabVIEW. Java is so easy to learn and understandable in LabVIEW. Yeah, don't feed the trolls. So now we get to the fun part. Control indexes. I like to call them control indices because indexes just sounds weird. Who's heard of control indexes? Okay, a good many of you. Who's actually used them? Okay, so I still hope you get something out of this. So what are these two functions? And I remember Tom with his keyboard presentation, he showed one of these nodes. There's one for setting controls by index, and there's one for getting control values by index. So yeah, I touched on that. I call them control indices because it's sort of like cactuses or hippopotamuses. But they're basically like value property updates that don't suck. So they're much, much faster, but they give you some of the same functionality with abstraction. They don't execute in the UI thread, which gives you a huge advantage already. So every controller indicator on a given VI front panel has a control index that's automatically assigned. And to my knowledge, they're just sequential. They start from 0 upwards, and someone can correct me if they know better than that. To update a control by a control index, you need 3 things. You need a VI refnum, because the control index is not necessarily unique across multiple VIs for obvious reasons. So the control index only applies to the VI that the controller indicator is on. You need 1 or more control indices for respective front panel controls, and you need values to write. And from what I think there's a slide further on, you need, if you're updating n controls or indicators, you need n respective values. So caveats. The VI with the controls or indicators must be in run mode, or they must be running or in run mode. Now, I've done them while they're running, and if there may be a way to trick VIs into run mode, and I haven't quite figured that out yet. But there might be a use for that. I already said they're only unique within a given VI. The control must have a terminal on the block diagram. So in other words, if you have a control or indicator in a cluster, you can't update it this way because it doesn't have a terminal on the block diagram. However, following that logic, a controller indicator can be updated on a tab control because it has a terminal on the block diagram, a respective terminal. And as a reminder, and this is true with any way to update things, if you set Boolean control values, they have to be in switching mechanical action. Boolean controls, not indicators. So I actually added this slide when Greg was giving his presentation. I'm like, yes, the word for this, or the term is structural polymorphism. And this is just a funny quirk. The way this works, you can write to a single index with a single value, multiple indices with multiple values. But one of the things that I actually do quite often is I write to multiple controls with a single value, but you can't do that for whatever reason. Going back to the benchmarking, control indices are way faster than definitely a value property node. They're not faster than a local variable, but the delay is pretty trivial, relatively speaking. So the disadvantage, or the advantage, sort of like the value update from a property node. It's very similar. You can have deeply nested code modules that can directly access the front panel controls and indicators, and this can be good and it can be bad. If you do it poorly, you can make some spaghetti and it might be tough to decipher. So,
and they are fragile. You delete one control and all the numbers are changed.
Interesting. Yeah, that's true, actually. But I think I count for that. So I wrote a class, and it's not really a super advanced class, but it's a way of sort of encapsulating all the functionality that you might use abstracting a user interface with control indices. And later on, I'll show that this class, every time you start up the application, will go and it'll pull in all the controls and determine all their control indices. So the renumbering it's not really a problem for this. So the way I wrote this is that a user interface VI can subscribe to the UI manager. Then the UI manager, as I just said, it traverses the front panel and it pulls in all the controls. For this implementation that I've done, it pulls in the control index, it pulls in the reference, and it maps all these things, and of course the name and the class. I've written some more advanced ones, but this is one that I wrote just for this demo. All right, and it also maps it to the owning VI, because I haven't gotten to unsubscription, but if the owning VI unsubscribes, then you need to know which controls are no longer applicable to your application. And one of the cool things about this is all the subscribed VIs are handled uniformly as if they're all one UI. So what does this particular implementation service? It services value change events from a user, which is what we're probably mostly after, and then also indicator updates from the application, as well as control updates, which is something you're going to want to do from your application perspective. And changes to values are propagated to all controls and indicators with the same name, which is the label text. And so basically any control or indicator that has the same label text is treated uniformly. And the caveat with this is they have to all be of the same type. And also when your user interface VI unsubscribes from the UI manager, usually this is the case when you close one of the UI windows, or maybe you present something different in a subpanel or something like that. Then the UI manager unmaps the VI, its controls, and their attributes. From a user's perspective, every user interface behaves uniformly, the interface is responsive, and if the application supports it, they can open and close different UI windows. They can interact with only portions of the user interface. So say you wrote a really complicated application and you've got a customer that only cares about like one little corner of this application, you can present them really easily with just a subset of the functionality. Or if you have other features disabled, or if you have classes that you can load in through packed libraries, whatever it may be. And from a developer's perspective, you spend much less effort and time creating user interfaces. You have a lot more flexibility, and you have very little overhead. And that's enough of the slide deck, because now I'm going to get into my implementation. And feel free to criticize away. So, all right, so here is the private class data, and I have several maps in here. I have a map that maps control names to individual controls. And the way I'm identifying the controls with a unique value is by converting the reference to, and I'll show an illustration here. Oh shoot, yeah, I should probably, I don't remember to zoom, so if I'm not zooming, let me know. This is awkward, I'm not used to this. One sec. That's not what I wanted. All right, here we go. So what I'm doing is, LabVIEW is already assigning a pretty unique, I think it is a unique key to each control and also each VI that I'm using. So rather than pass around all the references, which to me seems a bit messy, I'm converting that reference to a unique key as a U32. And the way I figured this out is if I cast it to a string, I always get 4 bytes back. So it works very conveniently that way. And accordingly, in my maps, so I'm referring to a control name, and it may have one or many, or even, it shouldn't have none. It could have one or many controls associated with that control name via this unique key, which is the control reference as a U32. Similarly, I made a map for the VI refs, because I don't want to be passing around VI references unnecessarily, because that could lead to memory leaks and bad things. And Then I map controls per VI, so if a VI unsubscribes, then you know which controls get unsubscribed. Otherwise, you might keep accumulating things that aren't valid, and that's not good. And one of the most important maps is the control attributes. So in this implementation, I am keeping track of obviously the VI ref, the control index. Yeah, so it's owning VI, it's control index, it's GObject class. I mean, it's not technically I guess it is sort of a GObject class, but I wanted to distinguish that from if it just said class, because like, what does that mean? Reference, and then of course the name. So with all these different maps, you can correlate where the control is, what it can do, what type it is, and yeah, I guess that's it. The other two things I put in here, so I have a UI manager, which is basically, it sort of acts like a mediator between all your user interfaces, and it's a loop that runs in one place. And so I have a user event that sends commands to it, almost like a state machine, and I call that the manager action. And then coming back from that, events that are sent elsewhere, the manager feedback, and I have Lumberg in there just because it seemed appropriate. Nerd humor. All right, so yeah, going through what it does. Yeah, so the initialize method isn't really that exciting. I just initialize the two events, and I have a mutex there to make sure that no more than one thread accesses the manager VI. And right now, it's not reentrant, but maybe at some point it will be. So I guess the mutex isn't really all that important. The manager itself is a single loop, and everything is through events. So what I do is I take all the user interface, the controls and indicators on your user interfaces, and I put them into an array, and then I put them into a single value change event. And then the user event for the manager action, that just allows the manager to be able to react to state changes. So I didn't use queues here because I'm already using an event structure, so I use user events instead. So here are the different states. You can subscribe, you can unsubscribe. You can set a new value from your application. There really aren't too many things in here because I didn't make this one that advanced. I wanted to keep it pretty simple. And then, yeah, where should I start here? I'll probably start with subscribing. So when a user interface VI subscribes, it'll run a method. One second. Subscribe. Yeah. So subscribing, the VI will send its reference, and it sends the manager action, which is a user event. It says it wants to subscribe. And once the event is received, the user interface manager will then traverse the entire front panel. So I'm using the traverse for GObjects, which is very useful. And it'll find all the controls, whether they're nested. And we're not so much concerned with what's nested in a cluster per se, but what's on a tab control. For instance, you want to be able to go through those things in a nested fashion. Otherwise, you're going to miss some things. And then it maps everything. So as I discussed before with the map, if it's already mapped, don't do anything with it. So if for some reason someone tries to map the same, or someone tries to subscribe the same VI twice, we don't want to do that. Right away, we take the control reference, we get some properties out of it, and those things get thrown into a cluster, and that's part of one of the maps. So that's the control attributes map. Then I'm mapping the names to control keys. So for a given name, you might have more than one control. So I set up a set of those controls, and then there's a map based on the name. Maps and sets, I actually benchmarked those two. I didn't want to take anyone's word for it. They are the most efficient way to look up values. So then I map the controls per VI. So I'll have, in similar fashion, I have for each entry in the map, I have a VI that's referenced by its U32. So its actual reference as a U32, which is a unique key. And then I have one or more controls in a set. not terribly exciting stuff, but mapping all that stuff. Unsubscribing. Actually, you know what? I'll just show a demo because this is getting a little bit dry. So where is my demo? So yeah, these are not pretty user interfaces. This is all proof of concept, and I just sort of like threw it together. So yeah. So I have one UI that's written in the Fuse design system. I have a modern one, and I have an old-timey classic one that I've just made as gaudy as possible. And I should probably, if I back up here and I show you one of these, let me just close the application actually. So if I close you if I show you one of these, there's really not much going on here. There's just control terminals and indicators, and I know other people in here have done it, so in different ways. I saw the JKI implementation of the Stargoat that uses something similar. So the only real sub-VI that I have to have this VI running. So that's one of the caveats. You have to have the user interface running, which means that you have to be able to stop it. So to keep it running, I just have a simple sub-VI that has an event structure, and if it receives an event from the UI manager, actually, is it from the application? Yeah, it's from the application. If the application says close that VI, it knows to react, and it closes itself. But yeah, the point is there's really no code going on on the block diagram, as minimal as possible. So that gives you a lot of flexibility in what you're doing. So going back to the demo, if I launch these 3 windows of different user interfaces, it is surprisingly snappy. Like it really keeps up. So I find this to be one of the best ways to manage my user interfaces. I use these all the time.
So show the writing code, how you write the indicators from it.
What's that?
Show how you send the value.
How I send the value?
Yes.
Okay. So that is handled by the value change event. So let me close out this demo. So in the UI manager itself, there's this event here. Here, let me zoom in. Sorry, I keep forgetting to zoom. This value change event that basically I take the aggregate of all the references from every subscribed VI, and I throw those into an array, and then I do a value change event. So when you modify one of those, when you change the value of one of those controls on the user interface, this event fires, and then, actually, where is that event? Oh, this is the value change. Is it? No, this is.
So UI manager catches all the changes to all the controls that
Exactly.
that in the application, and then invokes those set control by index functions to send the value to the VIs with the indicators to which you want to output.
Yes, and I probably didn't explain that well. So
You didn't.
my apologies. So yeah, when someone changes a controller indicator on the user interface, the UI manager receives the event through that value change event, and then it redirects. So this is the part that I didn't talk about, this control value event here. It sends out another user event, which, yeah, so that sends out another event to itself, and my apologies here. You know, I wrote this like 3 days ago, and I'm already like, what was I doing here? So yeah, it sends out the feedback. Okay, here's where I'm doing it. So it looks up all the mapped controls with the same label text or the name, and then based on that, I look up the VI index for whatever the control goes to, and then so I get the VI that it belongs to, the control indices, and I'm grouping based on this by the VI so that I have minimal transactions. So for each VI that's subscribed, I send out a series of control index updates. Really, it's just one. And that's how the values get propagated from one user interface to the other.
So you can't really send a calculation result, like whatever you got on some wire to whatever target indicator. You have to, your manager catches only changes in controls, just to send the value to some other VI's controls or indicators.
It
Do I
does
understand
that.
correctly?
But there's also another thing that it does, and it does just what you're talking about. So here's, and I only made one example of this. When from the application when the application wants to update the user interface, it can send out a special event just for that. And what I did is I just made a series of random numbers and it applied to all the user interfaces. So if I go to the terminal for this, so there's this this method here. It takes whatever value you have, you give it a tag that goes to any controller indicator on the user interface, and it updates those accordingly through the manager. So yeah, you can update the user interface from your application, and that's a huge part of the functionality here. Yeah.
So two things. The VIs need to stay run for all of this to work.
Okay.
As long as you run it and you can let it stop, and that stays in a reserve for run state, I believe.
Oh, I didn't know
But then
that.
all the set control, like you have to run it once, unless there's another trick anybody else knows to share.
I was trying to figure that out because,
But that's a trick I use.
okay, so you run it once and then, yeah, as long as the parent application stays running, then it's still in run mode.
Yeah, until you close all the references to the VI.
Cool.
That's at least my findings. And then the second thing, I'm curious why you're converting the references to U32s. Map keys can be control and VI references.
They can, yeah. So
Is there a reason for that, or?
especially with the VIs, I'm paranoid and I didn't want to pass around the references more than necessary. I wanted to keep them all contained in one map so that I know they're not being passed around. And like for me, it seems more prudent and there's less likelihood of a memory leak. Maybe my worry is unfounded, but that's why I did it. Controls, it's really less of an issue, but I did the same thing. I have done it by reference in the past, and I don't think I noticed any adverse effects, but you know, if something's left running for a long period of time, I could see that maybe being a problem. I don't know. No, thank you. I appreciate that. Any other questions? Yeah.
So if you're using this in an application where data is getting generated from a bunch of different places, right?
Yep.
And going to multiple user interfaces, how would you typically set up the connections between this piece of data goes with this control index or control name? Because there could be a big kind of set of that, right?
Yeah, you'd want to manage that in your application. This is really just the mechanism to service events from the user interface and also update the user interface. Certainly, you would want to have some organization. You know, like this tag does this or that, but that's really beyond the scope of what this does. You could build that into it. I haven't made one that does exactly that, but I've done some other ones that are more advanced. Yeah, go ahead.
Can we get a copy of your project?
I really want to. I don't know what the rules are with the company I work for. So like, I don't know how much if any or all of my, well, certainly the code that I write for my day job is owned by them. I don't know if it's owned when I do it in my free time. But otherwise, I'd love to share it because I think it's really useful. Another question?
Should you have a check for like if different data types have like the same name?
I don't have a check for that, but I've run into that in other applications, and I have it throw an error because it is easy to do. Certainly, you have to have the same data type if you're trying to send a value. Yeah, they all have to be the same data type, otherwise bad things happen.
And if somebody wants to simply write to a terminal in another VI, just like as if it was in the same VI, use my application.
Your application, okay. All right. So, yeah, any other questions?
Will it work for reentrants,
For reentrants,
guys?
I mean, it should. I mean, what's part of reentrancy are you speaking
I was
of?
just wondering about the two copies of the same VI. They're reentrant. Can you inject these control values and stuff?
Yeah, I mean, as long as they have the class, they can send the event, yeah. Another question? Oh,
Yeah.
I'm sorry. I don't know who had their hand up first.
Sorry.
Okay.
So this is just for value changing, right? Not any like property changing of the UI controls, like colors or things like that.
So in other implementations, I have added that. Like I said, I wrote this just for this demo. But yeah, that's absolutely something that I include. The ones that I use day to day, those have the property changes, especially things like visibility, whether they're disabled, position, and yeah, you could put color in there as well. But yeah, that is something that I use pretty often. Somebody else had a question?
That was essentially my question, but also, shouldn't Control M put you in run mode?
What's the question again?
To go into run mode, I think you can just Control M.
Okay. Yeah, I've used Control M to get out of reentrant VIs into the VI itself. What was that? Sorry.
No,
Is it working?
that wouldn't work in an executable.
Yeah.
Control M is
Yeah, that was my understanding too, and I don't think I've done anything with run mode with Control M, but yeah, interesting question. And I know I've sort of meandered around different parts of this, and it's hard for me to really teach it not teach it, but go over it in a really comprehensive way, because it's for me it's hard to sort of organize it. So if I've left out any details here, by all means ask me for more details. Okay. All right. Yeah, go ahead.
So, pardon my ignorance here, but the control or the function that this whole thing hinges on, the update control by indices, is that what it was called? What version of LabVIEW did that come up in? I mean,
think
has it been there forever?
No, it wasn't there forever. I think it was 13. Was it? It was definitely in 15. I think, yeah, I saw it in What's New in LabVIEW. I think it was 2013.
We introduced it for a very specific customer whose UI had become extremely large and complicated.
I knew there was some lore behind this. I don't know how
Yeah,
much.
so they were updating thousands and thousands of components
Yeah.
on dozens and dozens of screens for a control interface, and it was a performance issue. So we released it for them, I want to say 2018.
Oh, really?
The first version. Is it? Oh, okay, I'm sorry. All right, so I date myself.
I saw.
Okay, wow.
I saw
Time
Greg
flies
shake
when
his
you're
head
having
too.
fun.
So I don't know.
I think 1.2 is like it exists to aid in performance. So I just
And it
want to
does that
emphasize
very well.
because like I would speculate a lot of UIs here are perfectly performant. So like if you find yourself laggy or needing it, then it exists. But like it's not necessarily necessary for the average
Right.
software.
Yeah,
house.
I mean, and even the help blurb will say like, this is for more advanced architectures. I personally like it, even if I don't have a lot of controls and indicators, but I do acknowledge it's probably overkill for a lot of the smaller applications.
It's really misnamed. As you mentioned, you can write only to those that have a terminal. So practically this function writes or reads from a terminal, not the control. And that's why, and it's really fast because of that. There is an article investigating that there is no switch to UI thread and all that. It's literally 100 times faster.
Right, yeah, the benchmark is, it's unbelievable how much faster it is than,
And in my presentation yesterday, who not many people attended, I'm using the same functions, of course, in my application, but quite a different approach. I just create, very simple inline sub-VIs that, yes, have those indices as constants, but my application watches, and if the user changes the order of controls of the target VI, then my application automatically updates the constants, including the reference. I will give you the flyer you can see. So if anybody is interested, I still have a bunch of, uses the same function, quite different approach. And in my opinion, it's simpler, but it's up to you guys to choose.
Yeah, I mean,
These functions are the fastest thing, hands down, of any functions, any methods of passing a value, like the latest value, to an indicator or control
Right.
or read from it from one VI to another.
I agree, yeah. And if I missed a good portion of the presentations yesterday because I was actually working on this one, so if I missed your presentation, I'm sorry about that. Oh, okay, yeah. So, but yeah, if you have other ways of using these functions, I'm really interested. I find it, I had fun working with these, so. Yeah. I tried to make a ridiculous demo of this. It had a ridiculous amount of indicators to the point where like LabVIEW was very, very sad. Unfortunately, I didn't get it working for this presentation, but to the remark that you can use this with thousands of indicators, I have no doubt that you can.
The main problem with these functions, because of which you had to go this far through making all this, is you have to understand index fragility and the need to pull reference. But ideally, what we would want something when we want to abstract the UI, right? We want just to have a representation of a terminal in another VI with just one wire in ideal case. And we would like to have it as simple as possible.
Right.
So, which this is, of course, not that simple to implement.
Not to implement, no.
Right,
But,
so that's why I went the kind of another way around.
Right. Yeah, the way I've written this, it's more, if I refined it a bit and polished it, it's the kind of thing that I would hand off to other developers and like, hey, you can use this if you want. You don't have to worry too much about the innards of it. But, I mean, would I pass this off as it is? Maybe, maybe not. But yeah, if you have a simpler way to implement it, I'm interested. Any other questions? I think we got like 10 minutes left. All right. Well, I mean, I don't really have much more to show about this, so I guess we can end early. Is that a thing? Okay. I don't know. Am I allowed to do that? Thank you so much. Cool. Thank you.